Hi everyone, my name is Jaison Mathew. In this video, I'm going to talk about the CAPWAP discovery process in Cisco Wireless Lan Controller. Previously, Cisco was using its own proprietary protocol that is LWAP, and now we have an RFC standard 5415, and that is the RFC standard for CAPWAP protocol. And control and provisioning of wireless access point, that's a full form of that CAPWAP protocol. And you can follow this particular link to get more information about the protocol, because in this video I'm not going to cover the entire protocol mechanism and how it works in background. I will just give a brief idea how to do a configuration on the controller side, or how to do that discovery process to find make sure your APs are able to find the right controller in your network. When we talk about this CAPWAP discovery process, this is not a single method process, because we have multiple methods available in this process to find your controller. It's not a single method one. The first method APs uses is the broadcast. So it will try to find your controller sending a broadcast request in your VLAN, and I will show you after some time I will show you how to do that configuration so that you'll find your own controller from your network using a broadcast request. And second method is to use the information stored in the NVRAM, and I'll show you how to configure your AP from controller side to set those values, and APs can try to get that information from NVRAM and join on the controller by using that information. And third option is using an OTAP. OTAP means over the air provisioning. That was the protocol supported earlier in the releases, in Cisco releases. Now it's not supported because we are passing the controller information over the air, and that was causing some security issues in multiple client side, and Cisco stopped that support now, and most of the new releases don't have the OTAP support enabled. And fourth one is using option 43 and DHCP option 43. So DHCP option 43 is the widely used method in the CAPWAP discovery process. So most of the places we are clients are using option 43 as the primary method to find the controller. And last option is to use the DNS discovery. So there are some specific naming provided by Cisco, and if you are setting the DNS resolution, name resolution for those names, this APs will by default it will try to resolve that name to get the IP address of your controller from your network. Those are the five methods, the normal methods available on discovery process. So let me show you my lab setup and how it works in background. So let me log in into the controller first and show you how many APs I have, and I'll show you how to configure this. So I'm going to use the AP named as CAPWAP discovery. That's the name I given for AP. Show a CAPWAP client RCB is the command to find the information about your controller and where it's connected. So as you can see here, this particular AP is connected on name of 5521, and the IP address of this AP, the WLC is 9.9.9.10. Let me show you the same configuration. Let me show you the basic configuration of the AP. Config general and AP name. This one will show AP config general CAPWAP discovery is the AP name. So if you give this command, you will get the AP related configurations. And as you can see here, you don't have any switch configuration. Switch configuration is WLC information configured for the AP. Basically, this is the high availability configuration. It also called as AP priming, that allows a controller to set some values inside your AP, and it will be stored in your NVRAM, and it will be used by AP for next reboot cycle. That is, before we go into the priming option, let me explain the first method that is available on broadcast. So for that, I have a switch here. So this is the network switch for this particular AP, and show Let me show you the configuration. I already done the configuration in this particular switch. I'll just explain you how it works. So basically, this particular broadcast is going to hit on your VLAN, and whenever you are getting a broadcast, you have an option to send those broadcast request to request as a unicast. That is one of the option, and the other one is to set the forward protocol. So um, we have LWAP and CAPWAP for discovery process. If you are trying to come up with a factory default AP, if that AP is an old AP, maybe it will be trying to join using the LWAP protocol, because our controller, Cisco controller, supports LWAP and CAPWAP discovery method. So if you want to use any legacy APs that uses LWAP protocol, you have to enable forward protocol for UDP 12223. And if you have CAPWAP also, you have to enable 5246, and that will allow you to do the discovery using um, using 5246 protocol number, port number, sorry, port number for a CAPWAP. So basically 12223 is the port number, UDP port number for LWAP, and 5246 is the UDP number for CAPWAP. And this is the configuration you have to do it on your sorry, this is the configuration you have to do it on your switch to forward the packets into that helper address. And next one is IP helper address configured on VLAN of your AP. So right now APs are connected on VLAN 9, and using this IP helper address, the broadcast request coming from your network, it will get forwarded to this IP address as unicast. So this also can be used for finding your controller. So this is the method. You can use it as the first option, that is a broadcast request on your VLAN. Let me show you the second option, that is priming the AP. Right now I shown here that this AP don't have any priming information about your controller. So let me configure this particular AP for priming. For priming the AP, you have to go to the wireless tab, go into your AP, then you will have an HA configuration tab, that is high availability tab. Here you can give your controller name and the management IP of that AP and click apply. So when you do this, you can see this configuration is stored on the AP side, and this is the information stored here. So you can give up to 3 controller IP addresses in this, and it will be stored in the NVRAM of your AP, and that will be used for next reboot. I'll show you that how this information is stored in the NVRAM. And this is the second method. And third option is OTAP, and OTAP is not supported in this particular code. Currently I'm running 802.166, so that particular feature is not supported here, so I'll skip that here. And next option is to configure option 43, DHCP option 43. So when we talk about DHCP option 43 or DNS configuration, it completely depends on your network and what is the server used in your network. So Cisco iOS devices supports DHCP configuration, and you can have any third-party servers for DHCP, like it can be Microsoft server, it can be a Linux server, it can be anything. So I'm not going to cover that in this video, because you have a number of videos that covers the same scenario, how to configure the option 43 on any of the servers. So you can find multiple videos. So here I'll just cover only one method that uses our Cisco iOS to configure the DHCP option 43. So I already done the configuration here. My DHCP pool is already configured. So let me show you that pool configuration. This is the VLAN pool. I'm going to use it for VLAN 9, that is my AP VLAN. So this hexadecimal value for option 43. So basically, while configuring option 43, you have to give the value as hexadecimal value. So it's a type length format. So we have to use option type length value, and you have to use hexadecimal value for this. It's while seeing this option 43 configuration, you will feel like it's a little bit complicated, but it's not that complicated. Let me show you this number F104. So depends on your AP WLC IP. You have an option to set how many IPs you want to share using option 43. So here in this case, I'm sharing only one IP through this particular value. And let me show you how to do that conversion. So basically, option 43, you can follow this link to get more information about option 43. So this clearly shows how to do the configuration on option 43, how to do the values and type length values, and also type values you can set it based on that. So when you talk about into 4, so you have one IP address on the length. Into 4 is the length you have to give. So if you are passing only one particular IP, you can use F1 0xf. Sorry, one second. You can pass that information using F104. If you have multiple IP address, this F104 will keep changing. That 4 will become 8, and you can add the second IP. And this is your IP address converted into hexadecimal value. And there are multiple online tools available for converting your IP addresses. So this is one of the example. You can find it, find many of the IP address conversion tools. So I given my IP address in this tool, and I clicked on translate, and you can see this is the IP hexadecimal value. So this IP got converted into hexadecimal value, that is 0909090A, and this is the value I configured here. So if I have only one IP, this is enough. And if you want to add one more IP as 9.9.20, you get the value of 20 using any of these conversion tools, and 20 will be 14. So what you can do is config, go to your IP DHCP pool. Right now I have only one IP, so that's why I have option 43 here, and I'm going to change that to 2 IP configuration. So I can put this one as 8, sorry, 8, then 0A, then dot 090909 14. So after putting this configuration, now you are basically telling your AP that you have 2 IPs configured, configured for your pool, DHCP pool. So this is how you configure option 43 with multiple IPs. If you want to send multiple IPs, you can use it, use this method, and you use the tools like this for the conversion of your hexadecimal values. So that's how you set the option 43 value on your iOS devices. And next one is option 60. So option 60 is used for identifying your model. So this one uses VCI string, that is used for finding the AP model. So there are some specific naming VCI strings for each and every AP model. The same link provided here, you have the entire list of VCI vendor class identifier VCI string. So right now I'm using this string for 3800. For 3800 AP, you can use Cisco APC3800. This is the VCI string that you can use it for option 60 to identify your AP model and give this particular option 43 as hexadecimal value. So this is how you configure hexadecimal value for option 43. And next option is to configure the naming of a DNS server. So as I said, configuring DNS name or adding a host name into your DNS server is already covered in multiple other videos, so I'm not going to show that. It's already configured on my network, so I'm not going to do that again. And when we talk about this particular option 43, there is a problem that is going to happen on this discovery process while using the static IP of the AP. So let me show you how to set the values on static IP address configuration. So for an example, I'm using the same AP here. I'm not going to configure it. I'll just show you how to do that. So in this particular AP, right now it's using DHCP IP address, and I'm going to enable static IP for this particular AP. So IP address and everything will be coming. Along with that, you have to give your DNS IP here and domain name. If you enable the static IP configuration, you have to put your DNS name here and domain name as your network domain. Otherwise, this AP will not be able to use DHCP option like domain name resolution, DNS name resolution, because it's not trying to get anything from your VLAN. Because it's not going to get any information. It's not DHCP information 43, option 43 or 60 or anything. It will not be getting passed to this AP because it's using a static IP. So you have to, if you are using static IP in your network, you have to also configure DNS IP and the domain name here. Then only that name resolution will work. Okay, so this is how you do DNS configuration on uh, static IP configured APs. So we covered high availability, how to do the AP priming here, and let me remove this and show you how this AP discovery do it in background. AP will do it in background. Let me reset this AP now so that you will see how AP tries to find the controller in background. So I'm resetting this AP, and let's see how it works in background. So I given the instruction to do the reboot on the AP side. Let me increase the size of this window to get more clarity. So now AP is rebooting, and see how it's booting up with and trying to find the controller here. It will take some time, but I'll keep it running so that you can see the progress happening in background. Okay, now this is going to start the CAPWAP discovery process, and as you can see, DHCP IP is assigned from DHCP server, and you can see here it's a DHCP IP is assigned from your our server, DHCP server, and it started logging on your default IP, and this is the domain name. I talked about the domain name. So right now this AP is trying to resolve the name as a Cisco CAPWAP controller. That's the name it's trying to resolve. And here you can see option 43 is getting passed from your DHCP server. So DHCP server passed the IP address of 9.9.10 through your VLAN, and it's successfully joined to 9.9.10 via router using UDP port 5246. So join request is sent, and it got the join on the controller. So this is how the boot sequence works, and how it works in how it will do the normal discovery process using option 43. This is how we do the configuration for multiple methods available in CAPWAP discovery. So hope this one will help you in configuring and getting the APs connected to your WLC in your network. Thank you for watching.